Good evening, everyone. I'm Aishwarya from University of Hyderabad. So today we are going to start the first tutorial session of Basics of Material Engineering. I hope all of you can see the slides. Can you hear me? Hello? Hello? Hello, can you hear me?
I can't hear your voice actually. Can anybody speak something?
Hello,
Yes.
can you hear me?
Hello.
Yes. Now, are you able to listen my voice properly?
Yeah, we are listening.
Yeah. Okay. Fine. Okay. So we will start the session. So subject, the title is Basics Materials Engineering, Basics of Materials Engineering. So the course later is introducing crystal structure, then imperfections in solid, imperfections in mechanical property, failure of material, basic fracture mechanics, fatigue failure theories, and phase diagrams. Okay, so these are the main topic. So first, I hope all of you listened already the SARS lecture. Whatever he taught already. So we will go to the problem solving session. Actually, this is a problem solving session related to your assignments, and Okay, so we will go to one by one problems and we will discuss the answers here. So it's related to your assignments also. You can see it from, it's not exactly your assignment question because I'm not allowed to do the last week assignments now. So we will discuss assignments slowly, but it's similar questions related to the assignments. Okay. So first the basic crystal structure, you know already, start with FCC crystal structure, B symbol cubic and BCC hexagonal type, all these things. So we are going to solve such kind of problem first. Okay. So the first question is, what is the atom per unit cell and a coordinate number of an FCC lattice? So how you have to find it? So in an FCC lattice, where the atom will be all the corners plus each face, right? Okay. So in each corner, what will be the atom? So 8 corners are there. So 1 by 8 atom is the contribution. So total will be 1 atom. Okay. And in each face what will be the contribution? So 6 faces are there. So contribution will be half. So total atom will be 3. So now the total atom in the FCC unit cell will be 1 plus 3, that will be 4. So this is the number of atoms in the unit cell. Now how we have to find the coordination number of it? That is the next question here, right? So now if you imagine, consider in the FCC lattice the face-ended atoms are the nearest and the corner atoms are surrounded by four spaces, like upper and like total 4 cubes, how it get that, like that. So the corner atom will be surrounded by 4 faces and the x that will be the x plane, and 4 faces will be in the y plane also and z plane also. So totally 3 plane there will be 4 atoms. So it's like that, 4 into 3 total 12 face-centered atoms will be there. Okay, now if we consider the atom at the face center and it is surrounded by 4 corner atom of its own plane and the adjacent atoms 4 and like above and below plane, then it will be, then also we can consider 12. So each atoms in the face and means FCC crystal atoms will be shared by other, means nearest neighbor will be 12 atoms. So we can call it as the coordination number will be 12. So this is the first question, how you have to find the number of atoms per the unit cell and the coordinate number. So here actually you have to know about each crystal system and how the atom will be and what are the various lattices it has, that is like FCC, BCC, HCP, all these things, and you have to know about the this atomic packing fraction and Miller indices. These are the basic things you have to know from the first week class. Okay, now we are going to solve the next problem. What is the atomic packing density of BCC? So what is BCC? Base centered, or means body centered crystals, right? So in BCC, the atomic packing fraction of a BCC crystal structure is equal to the volume of the atom in the unit cell divided by the volume of the unit cell. So we can write it is like atomic packing fraction is equal to V atoms divided by V unit sphere. Okay, so what will be the, now we should know how many atoms in the body centered. So body centered crystal also, it will be like okay, one atom will be in the body, inside the center of the unit cell, and others will be the corners. Okay, so total contribution from the corner, it will be already know, it will be 1, and in middle there will be 1 atom, so total 2 atoms are in the body centered crystals. Okay, so if you think each atom has radius r, okay, so the total volume of the atom will be what? Volume of atom is equal to 2 into 4 by 3 pi r cube. Okay, so that is the volume of the atom. Now volume of the cube, it will be what? The side is A, then the total volume of the cube will be A cube. Then you can see APR, the atomic packing fraction, it will be 2 into 4 by 3 pi r cube divided by A cube. Okay, now in front of the BCC, the relation between A and the area, means unit cell's length and area, with that is A is equal to 4 by root 3 r. Okay, so substitute that here, you will get the packing fraction, it will be 0.68, that will be 68%. You have to substitute this A value here. Please go through these two questions, then we will go to the next question.
Hello, ma'am. Ma'am, A is equal to 4 by root 3 R. That is only for BCC or general formula?
It's only for BCC. Each one will be different, that we will solve later. Okay. There will be one problem is coming like that. This is now only for BCC. Okay, now we will go to the next problem. So next problem is you have to solve the Miller indices. So the question is, in a crystal, a lattice plane makes an intercept of length a 2b and minus 3c by 2. Find Miller indices for this plane. Okay, so here what is given? Intercept of plane, that is how much? A 2b minus 3c by 2. Okay, so from that we have to write the intercepts. So intercepts will be 1, 2, minus 3 by 2. Oh, sorry. Minus 3 by 2. Okay. Now what you have to do, you have to take the reciprocal of it. So when you are taking reciprocal, it will be 1 over 2 minus 2 over 3. Okay. Now what will be the LCM of it? It will be 6. You have to make it as a whole number for these all reciprocal numbers. Then it will be, you have to multiply this LCM, then you will get the Miller indices. So Miller indices will be 6, 3, minus 4. So this is the procedure you have to calculate the Miller indices. First you have to know what is the intercept of the plane. After getting that plane, you should take the reciprocal of that intercept. After that you have to make it as a whole number. Okay, then everyone please try to do the next problem, fourth one. In the figure given below, find the points having a direction of Miller indices 0, 2, 1. So you have to find which point having the Miller indices 0, 2, 1. So for that they have given actually 4 lines, that means for direction, that is A, B, C, D. Okay, so in this which one have correspond to 0, 2, 1, you have to find it. So if you have 2 points, like consider one point is x1, y1, z1, and another point is n, that that is x2, y2, z2. Then the direction is given by x2 minus x1, y2 minus y1, z2 minus z1. So similar way you have to know from A is what, B is what, C is what and D is what, and find its corresponding. So I am calling as A1 and A2. So A1 will be 1, 0, 0, and the other end of A will be, that is A2, it will be 0, 0, 1. So now you have to find what will be the Miller indices. Similarly, B1 is half, 1, 0, and B2 is 1, 0, 1. Okay. Similarly, C1 is 0, 3 by 4, 1. C2 is 1, 0, 0. Now D1 is 0, 0, 0 and D2 is 0, 1, 1 over 3. So you use the formula and find which one will be the answer for this question. So find the Miller indices of like the points, and you will get it. You will get the point. You have to take the reciprocal of it and find the answer. Please everyone solve it and let me know what will be the answer for this question. So did anyone try the problem? So what will be the answer here? So if you find this, what will be the difference first of all? It will be minus 1, 0, 1. Right. So your Miller indices will be reciprocal of it. So it will be minus 1 divided like its reciprocal minus 1 and 0, 1. So this will be this answer. Okay. And here what will be the answer? 1 over 2 minus 1, 1. So the Miller indices will be 2 minus 1 over 2, 1 over 2. It will be, sorry. It will be 1 minus 2, 2. Okay, now C will be 1 minus 3 over 4 minus 1. So the Miller indices will be 4 minus 3 minus 3 minus 1. Okay. Now the last one, it will be 0, 1, 1 over 2. So your Miller indices will be 0, 2, 1. So the question, this is the answer. So you have to just subtract it and find the reciprocal. So the Miller indices procedure is this one. You have to find the intercept of the plane and reciprocal and make it a proper whole number. That's what I have given here.
From the first and second point, any point can be taken.
No, it's first and second. No, the option D point is the correct answer. The third question is 0, 2, 1, right? We are getting D is 0, 2, 1.
Ma'am, for taking, for example, C1 and C2, if I take 1, 0, 0 as C1, like if we interchange,
No problem. It will be same.
okay.
If you have done this problem, please go to the next fifth problem, the Miller indices of the plane, which is given in the below. So first you have to find what is the intercept of that plane. Okay. Then you have to find the reciprocal. Then make it as a whole number. So first think about what will be the intersection, because it's not in the x or y or z plane. It's just in the cutting the corner. So you should know what are the indices for the intercept. So how to find it? Okay, here if you see, this is x-axis, this is y-axis, this is z-axis. It's crossing the x-axis at the distance a by 2. Okay, half of it. Y-axis also half of it. So we can write it as a by 2. It's not touching the z-axis, so it is going like parallel. So we are writing it as infinity. So the intercept will be a over 2 and infinity. Okay, now you have to take the reciprocal of it. So first of all we will say it is 1 over 2 infinity. Now take the reciprocal of it, you will get 2 2 0. Okay, so this will be your Miller indices. So this is actually easy, but you have to know what is the intercept exactly. If you are done with this problem, please do the sixth problem. So listen the sixth problem. It is a unit cell of a crystal is shown in the figure. The Miller indices of the direction as shown in the figure. So arrow direction, it's coming from 0 to here. So you have to first write what is the x coordinate, y coordinate and z coordinate, and take its intercept and take its reciprocal. Then you will find the answer for it. Okay, so please do it. So what are the intersect here? So if you see here, the first point it will be 0 0 0, and the second point it will be how much? Half, because it's touching x-axis a half distance here. Okay, and y is 1 and it's not touching z-axis, it is a 0. So half, 1, 0. Okay, now what do we have to take? You have to take the difference of it. So it will be half minus 0, it will be half. Okay, 1 minus 0, it will be 1, then 0. So this will be the directions. Now we have to convert this as the integer. So you have to multiply with 2, then you will get 1, 2, 0. So this will be your Miller indices for in that direction. Okay. Now let us go to the other problem. So till now we have discussed normal cubics. Now see this question, the Miller indices representation of a crystallographic direction 211 in HCP crystal system. HCP crystal system means how it's look like? So it will be okay, something similar like this. So here there will be Miller indices will be actually not the 3 component, it will be 4 components. Okay, that we can write it as capital H, K, then I, then L. Okay, so we have some formulas to find it. So we are representing this one similar HKL. Okay, so H is 2, K is 1, L is 1. Now we have to find this Miller indices for the HCP system. So for that there is a formula, you can use it 2H minus K divided by 3. That is a H. And K will be 2K minus H over 3. Okay, I will be minus of H plus K. Okay, then L will be I. So now you find it using this formula. You have already the small letter HKL, the value 211. Use this formula and find the HKL values. Then you will get the Miller indices for the HCP crystal system. So it will be 4 components. हेलो कहाँ भैया आ रहा हूँ भाई hello, what is the answer you have got? What is the answer? Please keep it in chat box. We'll discuss it. You can type it in the chat box. What will the numbers you have got the answer? Yeah, most of them have, there are two responses I can see it. 1, 0, minus 1, 1. So that is correct answer. Okay. So you substitute the values. You will get the answer 1, okay, 1, 0, minus 1, 1. Okay, so this will be the answer for this question. Now see the next question. The electronegativity of a H, hydrogen, and chlorine are 2.1 and 3.0 respectively. Then the percentage ionic character of HCl is what percentage? So you have to find the HCl percentage ionic character. So normally using electronegativity value, the percentage of ionic character could be calculated by the, like, one formula is there. So percentage of ionic character, so it will be 16 delta E plus 3.5 delta E square. Okay, so delta is the electronegativity difference of two atoms. So you have already know 2.1 and 3. So the difference will be, our delta E will be electronegativity changes difference, that will be 0.9. Now you have to just include that 0.9 in this formula and find the percentage ionic characteristic of this HCl molecule. Okay, so please substitute and do the answer and keep your answer in the chat box. Yeah, the answer, whatever you have got, 17.2%, that is correct. Okay, so it will be 17.2%. So the percent ionic character of HCl molecule is 17.2%. Okay.
Then there is another formula involving exponent.
Okay.
Shouldn't that be used, ma'am?
You can, if the same, giving the same result, then you can use it, no problem.
That is giving 18.3%.
18.3. How? Which formula it is?
1 minus exponent of minus 0.25 multiplied by xc minus x.
1 minus e to the power minus en square by 4, right? Same. To check the covalent or ionic nature, yeah. So you can use that formula also. This is only to predict the ionic character. Okay, that formula will give the, like, how much like ionic or covalent character it will be.
But the answer is different.
But it's differing from, well, like 1 point, I mean one value, right?
Yes,
think that's not a problem. Because exponential term will come, so you have to calculate, use the calculator, so it will be round up, then it will come. That's not a problem. Okay, so go to the next problem. The atomic weight, density, atomic radius of a hypothetical alloy are 77.4 gram per mole, 16.05 gram per centimeter cube, and 0.5 nanometer respectively. Okay, so the density formula, which is given Na divided by Vna, where N is the number of atom, A is the atomic weight, V is the volume of the unit cell, and N is the Avogadro number that you know already, 6.022 into 10 to the power 23 atom per mole. Okay, what is the crystal structure of this alloy? So how to find it? You have given all the details of the crystal, but you have to find what is the crystal it is. How you can find it? See, weight is given, like atomic mass is given, density is given, atomic radius is given. So if you know atomic radius, you can find the volume, right? So what is missing here? N, right? Small letter n, number of atom is missing here. So if you know the number of atom, you can find which crystal system is this, because symbol cubic, the number of atom is different. FCC, the number of atom in the unit cell is different. BCC, the number of atom in the unit cell is different. So if you know the number of atom, you can predict which crystal structure it has. Okay, so first you write what are the parameters which is already given in the question. Okay, so A is given, that is 77.4 gram per mole. Okay, density rho is given, 4.20864 gram per centimeter cube, and R is given 0.1 nanometer, that is 0.1 into 10 to the power minus 7 centimeter, that you can write it as 0.8 centimeter. Now from the formula, find the value of N. N will be rho V N A divided by capital A. Okay, now what is the volume? Assume that volume of the unit cell will be A cube. Okay, assume that A will be mR, because if you see symbol cubic, A and R relation will be different. Okay, like R will be there in the formula with multiplying with some constant K, that we are calling it as M here. Okay, because BCC, we have already seen the relation of BCC with respect to this in the first problem. A will be like 4 by root 3 R. Similarly, each cubic system has different one that we don't know now, so let it be mR. Okay, now substitute all the values here. Okay, then it will be m cube r cube. Volume will be m cube r cube. Substitute all the values in the n formula and get the value of n first. Okay, then from there you have to find what will be n by m cube. Okay, first do it, then we will discuss how you will get the crystal structure. Okay. Write the n value in the chat box. Okay. Yeah, how much is the n value you have got? Okay, you please divide it by this n by m cube also. Okay, then you will get the n by m cube value is 0.125. Okay, now I am giving a table of values here. Okay, number of atoms, m value, n by m cube value. Okay, so in simple cubic the number of atom is 1, m value is 2, so it will be 0.125. okay, for BCC it is 2, m value is 4 root 3, 4 over root 3, it will be 0.162. okay, for FCC it will be 3, 4 over root 2, this is 0.1325. okay, now HCP it will be 6 to 0.75. okay, now the A and R relation for simple cubic, it is A is equal to 2R. Here root 3A is equal to 4R. okay, here root 2A is equal to 4R. here A is equal to 2 by 6R. That's 1 over 3R. So this is the relation. So you should remember what are the number of atoms and what is the relation between them. Then you can easily find the solution for it. Okay, so now see we got 0.125. So the answer is simple cubic structure. Okay. So this is actually very simple question, but tricky question. Like you have already studied, I think in the class, so I taught already number of atoms in each crystal structure. You know what is the relation between the radius and unit cell length, but they didn't ask it directly. They just ask it in the tricky way. So you should know how it will be. Okay, how you can connect it. Okay, now we will go to the next problem, but please remember this problem, which is very important. Okay, now the next problem, we have solved this kind of problem earlier, so you have to just apply the formula once again, or otherwise you can use another formula also. Okay, so if the electronegativity values of manganese and chlorine are 1.2 and it's magnesium and chlorine are 1.2 and 3 respectively, percentage ionic character of MgCl2 is. So same, you can use earlier formula, otherwise you can use the another formula also what he told earlier. The percentage of ionic character will be 1 minus e to the power minus delta E square divided by 4 into 100, like percentage. Okay, so again here you have to find what is delta E, substitute it in the formula and find the answer, how much percentage it is. Okay, and see the system is perfectly ionic or mixed off, the bonding is mixed off, ionic or covalent. substitute and let me know how much you are getting the answer. Oh, sorry, do you want to explain me the m value again? Hello? Someone asked question in the chat box. Okay, I'll discuss that in the last of the class. Okay, once again, that problem. So now you please do this problem in wind up time. I'll discuss it once again. Just write what is the answer you have got. So your delta E value will be 1.8. Substitute that and you will get the answer. Okay, so some of you are keeping the answer, it's correct. You have to substitute the delta E value, it is 1.8. Then your answer will be 55.5%, approximately 56% ionic character. Okay, so this is just easy problem. You have to remember that there are two kinds of formula. Just remember the formula and substitute it, that's it. Now see the number of atom per unit cell in a crystal lattice. The question will be, can any of the crystal lattice number of atoms per. So how you will calculate it? Okay, so there will be three different kind of crystals. One is simple cubic. Okay, another one will be FCC, then VCC, So in simple cubic, the atoms will be, we know already it is atom will be in the corner. Okay. So before that, we will write some contributions. Okay. Contributions from corner. How much it will be? It will be 8 into 1 over 8. Means total contribution will be 1 over 8. Okay. In the unit cell. Now contribution from the face side. How much it will be? 1 over 2. From the body center, it will be 1. So this you know first of all. So here 1 by 8 and there are 8 atoms. So it will be 1 into, means 8 into 1 over 8. So it will be 1. So for simple cubic, it will be 1. Okay. Now what about FCC? FCC is face centered. So each face, it will contain the atoms. Okay, and corners also. So corners I am not drawing here, but you should understand it. Then it will be 8 over 1 over 8, 1. Then similarly 6 face into 1 over 2 contribution, it will be 3. So total 4. Okay. Now if you see BCC, BCC what you will get it? Body center 1 atom will be there and 8 corners atom will be there. Okay. Then how it will be? 8 into 1 over 8, that is 1. Then middle atom, so 1 into 1, it will be 1. So total 2 atoms. What will be in the case of HCP, hexagonal crystal packing? So hexagonal crystal packing, actually you can see there are atoms in the corner, but here total 12 corners. Okay, upper part 6, lower part 6, so total 12 corners. So 12 into how much it will be? 1 over 6, because 6 contribution, and it will be 2. Okay. Now there are 2 atoms in the faces. So upper face 1 atom, lower face 1 atom. So it is face atoms. Okay. So there will be 2. So 2 into face atom, it will be contribution will be 1 by 2. So it is 1. Okay. Now inside there is 3 atoms in the FCC, means HCP crystal structure. So it will be 3. Inside it will be 3. So total atom is 6 in the HCP crystal. So this you should know. Okay, how many the total atom contribution in the unit cell. Okay, I hope all of you understood it. Okay, now we will go to the next problem. Next problem, we are finding the A and radius lattice side ratios of the FCC crystal. It's just FCC crystal. What is the relation between A and the radius of the atom? R. Okay. So for FCC crystal, if you see it's one side. You can draw only one side. Okay, it should be cubic. Okay, there will be center atom and atoms are in the corners, right? Okay, so if you draw a line like this, okay, it will be the radius is R, total R, here also R, here also R. Okay, and this distance is A. Okay, so if you draw a triangle, it will be A, 4R. Okay, so you can use the Pythagoras theorem. So A square plus A square is equal to 4R whole square. So it will be 2A square is equal to 16R square. A is equal to 2 root 2 R. So this is the relation. Similarly, you can do for cubic system also, like simple cubic. Okay, there will be only R. So it's very easy. A is equal to 2R. My drawing is not that much good. Now, if you see face-ended crystal, it is little tricky. Your imagination power should be there actually. The atoms will be like one corner. It should be in one corner, and the body is centered, and it's in another corner. Okay, my drawing is not that much good. So R, it's passing through the diagonal of the crystal. Okay, so it will be like, how you can make a triangle? It is like this. Okay, so if you see, it will be, we are calling this distance as D. Okay, this diagonal distance as D. Okay, it's a diagonal from this side. Okay, this diagonal and that diagonal and one side and this. So it will be look like this. D will be what? A and A. It will be A square plus A square, that is D square, Pythagoras theorem. Okay, so D will be root 2A. Now what we have to do? We have to know from this triangle it will be root 2A whole square plus A, that is one side is D, another side is A, and its diagonal element, that will be 4R, because these 2R, here are 1R, here 1R, so total 4R. So it will be 4R whole square. Now when you are solving it, you will get root 3A is equal to 4R. So A is equal to 4 over root 3R. Okay, so please go through it. It's very important. go to the next question. So next question also it's similar like the formula what we have used earlier. So what is the density for a FCC system with atomic weight 63.5 gram per mole and atomic radius 1.28 angstrom? Okay, so here what is already given? Atomic weight A is already given and atomic radius R is also given. Okay, now we know the formula. The average number of like you know the already formula of density, it will be Na divided by V Avogadro Na. Okay, Avogadro number. So here already it is FCC crystal system, so you know already volume how to calculate it. Okay, for FCC we have now already find the relation between all those, so you have to find like that. Okay, then A value is already given, Avogadro number is already know, and it's FCC, N value also you already know, you can calculate the density directly. Otherwise what you can use, density is equal to N over M cube, that already I have given in the earlier problem. Then you no need to directly find the volume, you have to just substitute N over M cube what it is and A divided by R cube Na. So this one also you can do it actually. So you can use any of the either of this formula. This is the direct formula. Here for the volume we are substituting this part, N by M cube R cube. Then you can directly solve it. So substitute all the value 4 into 63 point whatever the value is given and find the value of the row. Okay, and please keep it in the chat box what is your density you have got it. Please keep it in the chat box. What is your answer? You have got it. The density value. Okay, so please find the answer for that question. Now we will go to the another question. It's very easy. Sketch the correct planes. Okay, so from here the Miller indices which is given, you have to find the correct plane accordingly. So here it is given 1, 2, 4. So one to 4 Miller indices will mark in the square bracket. Okay, so 1 to 4 will be what? It will be the plane value. So it will be like, first case the plane will be like this. 4 is 1 is here, this a-axis, 2 means double of its length. Okay, then 4 means 8. So it will come like a triangle. So this will be that plane. Okay, next one is 1 bar 0. So how much it will be? 1 bar 0. It will touch here. 1 bar in negative axis and 0 means, so it will be in the below plane. Okay, and here 0, 1, 2. 0, 1, 2 means you have to take the reciprocal of it. It will be, so infinity 1 over 2. So infinity means it's not touching the a-axis, and 1 means it is touching the y-axis, and another one is 1 over 2, so half of the z-axis. So it will go parallel to z axis and parallel to x axis, and the plane will be like this. Okay, so it's like a reverse process. The values are given. You have to find the Miller indices and according to the planes. Now see this problem. You have to find the appropriate Miller indices. So can you please do it? Two planes are given, first two pictures, and another one the direction is given. So each case you have to find the coordinate first, like intersection first, then take the reciprocal of it. Then you will get the answer for that question. And try to solve it and keep the answer in the chat box. It's very easy question. You have to just solve it. Do the Miller indices problem for idea. So see here, it's crossing the A part half, B part half, C part half. Okay, so half, half, half. So it will be 2, 2, 2, the reciprocal part. Okay, and here it's touching A fully, so it will be 1. Y-axis is not touching, so it's going to the y-axis parallel, so it will be infinity, and it's touching z-axis at 1, like completely, so 1. So it will be like 1, infinity, 1. So if you take the reciprocal of it, you will get 0, 1, 0, 1. Okay, now here what is happening? It is touching x-axis at 1, y-axis at half, and z-axis at 1. And it's going opposite direction, like touching minus y-axis we can say. So it will be 2, 1 bar. So this will be the answers form. You have to know where is the intercept first of all. Then you have to solve it. So I think most of the answer was in the chat box, both are different. So please go through it, okay?
Then for the first one, towards the z-axis, it is given 8 Armstrong, which is double than the other two axes. So how can half be considered?
No. The total length of the unit cell in the axis is 8, and it's crossing the half of it. It's like that. You should not relate with how much is the a-axis length, how much is the c. From the total length of the c-axis, how it is related. That's it. It's not that you have to compare with the other axis length. Okay. Because its unit cell shape is like that. It's not cubic. Are you getting?
Yes, ma'am.
Yeah.
Ma'am, in the third one, why negative 1 by 2?
Yeah, that is actually, see, normally how we will draw the directions. It will start from left to right, like this or like this.
Yes,
It's
ma'am.
coming the opposite direction. So that's why I took it as a negative. Because it's a
Okay.
vector. You should know. It's not a plane. We are giving a Euler indices for a direction. That's it. everyone, please note these questions. The three-dimensional arrangement of atoms that you know already. Okay, and these two questions you please note it, and we will discuss it in the next class. So please note it and try to solve it. And you will get the this class video link by this week. Okay, so you can see this question through the video link also. You will get the this material also, how I solved all this PPT also. You will get it too from the NPTEL section. Okay, you can, I think you will can access from the NPTEL portal regarding this video link and all. So I think someone asked the doubt about what is the M value. No, here in this question actually someone asked the doubt what is M value. M value is nothing but the constant. Whatever the we are writing the relation between A and R, the numbers will be coming here, right? 4 over root 3 or 4 over root 2 or 2 or 3. These number we are calling as a M as a constant. That's it. But it's nothing but important. But if you know this, the problems will be easily solved. Otherwise, you have to remember every time how to generate the relation between A and R. That's what you have to remember then. So today we have solved the problems related to the basic crystal structure, how the each crystal system and its packing fraction, A and R relation, and Miller indices and density formula. So these 4 problems we have discussed in different way and different type of questions. So please go through it and study it. It will be useful for to solve the assignments and as well as the to clear your exam. Please explain that. Okay. I hope, do you have any other doubt from the today's class? I hope all of you understood today's class. So attend such lectures carefully, and if you have any doubt you can ask here in these live classes, and it will continue every week 6 to 8, every Monday evening 6 to 8. The same Google Meet link, you can attend it, you can ask the question next class also. Otherwise, if you are in any doubt in the while listening the class or something, in the NPTEL forum itself you can ask the questions. There will be an option for that. Ask the question, we will answer for it. Okay. I hope all you understood. So we will see in the next class. So we'll discuss more questions on the next week questions in that class. Okay.